Hi everyone. I promised a video on kind of the minimizing and maximizing type of things, the word problems that we get. And so I wanted to do just a couple of them. I think I'll split it probably into two videos because one's a little different than the other. So um, the first one here, suppose the manufacturer of a gas clothes dryer has found that when the unit price is P dollars, the revenue in dollars is R of P is equal to negative 4P squared plus 400P. At what price is the revenue maximized? So whenever you see the word maximized or minimized, you should be thinking of the vertex, especially when you're seeing something that's a quadratic equation. Okay, so that's a quadratic function there. So you're going to think, I need to find the vertex of this. So let's go ahead and find the vertex of that. If you remember, the vertex is negative b over 2a. And in this case, I guess, r of negative b over 2a. If we look, though, at what we want, all we want is the price, and that's going to be the p-value, the value of p right here. Not really the p-value. The value of p, this is going to be my price, because this is my revenue, right? Okay, so not too hard overall. What we do is, if we look, remember this is a p squared plus b, p plus c. And so we're going to take negative of 400 over 2 times negative 4. So what you're going to get is negative 400. This is negative b over 2a. Okay, negative 400 over negative 8, which is going to come out to 50. We want to make sure that we say what it is in the real world. Here, it's the price in dollars. So our answer would be $50 would maximize revenue. So at least give me the $50 part. All right, you want to at least put it in something that's pertinent to the real world so that we can see what it looks like. So let's take a look at another one. Here we have a farmer with 400 meters or 4,000 meters of fencing who wants to enclose a rectangular plot that borders on a river. If the farmer does not fence the side along the river, what's the largest area that can be enclosed? So here we have, here's my river. See, lots of water flowing. And I'm going to build a fence around. So here's my fence, and I'm going to put little animals in it. And it's going to have, let's say, a length of x and a width of y. Okay, some length and width. And both of these sides, since it says it's a rectangular plot, we know they're the same. So this side is also x. So if I look at the total length, the perimeter of my fence, then I notice that if I were to walk along it, consider walking along the fence, then I have x plus y plus x, and that gets me all the way around his fence. And that's just equal to 2x plus y. And I know that the total length of my fence for 2x plus y has to be 4,000 meters because that's the most fencing that my farmer has, right? Actually, I'm going to leave the meters off just because otherwise it's going to look like a variable. So it's 4,000 meters long. Now, what I want to do is I want to find the largest area. That means I want to maximize, oh, it erased. I want to maximize an area. So I know that the area of this, if I just think of it as a box, right, is x times y. Now I have two variables in this equation, and I have two variables up here, and I want to just get one. So if you even consider what we're doing with the systems of equations, the easiest thing to do is to substitute into my area equation. That's what I want to maximize from my equation about the fencing that's up here. So in this case, it's easiest for me to solve for y. So I'm going to say y equals 4,000 minus 2x. And I'm going to take that and I'm going to substitute that in to this equation for y. So now I'm going to have the area as a function of x is equal to x times 4,000 minus 2x, which is just equal to 4,000 x minus 2x squared. Now again, I want the largest area, so you're looking at a quadratic here, right? I have an x squared and an x term. So I'm thinking the maximum area. And whenever I think about a maximum or a minimum, I think about my vertex. So I'm going to think about negative b over 2a, and my maximum area, the actual area, would be negative a of negative b over 2a. So in here, I actually want to find what is the largest area that can be enclosed. So I want to find this. So let's start by finding the x value for my vertex. So in this particular case, negative b over 2a is just equal to negative 4,000 over 2 times negative 2, which is negative 4,000 over negative 4, which is going to be 1,000 meters. This is going to be my x value. So that means that this side is 1,000 meters. It also means that this side is 1,000 meters. We could actually go back up to our equation here, okay, to this equation, and I could say that means that y equals 4,000 minus 2 times 1,000, which is equal to 2,000. So I know that the length over here is 2,000 meters. So I have all of my dimensions. At this point in time, I can do one of two things. I can substitute into my equation for a of x, because I know that x is equal to 1,000, or I can substitute into, or I can just use x times y. So, and you'll get the same answer either way. So if I use a of x, I'm going to find a of 1,000. And that's going to be equal to 4,000 times 1,000 minus 2 times 1,000 squared. And if you multiply that out, what you should get is, it's very big, 2 million meters squared, right? Because I multiplied meters times meters, right? If you think of it just with the equation for a, then we could say it's x times y, which is 1,000 meters times 2,000 meters, because that was my y term. And this time I left the units on them. Notice that you're multiplying meters times meters here. That's where the meters squared comes from. So if you do that, you get the same answer, 2 million meters squared. All right, so either way you can find the answer, both of them work. Alrighty. Let's do a little bit of a variation to this. And we're going to say, let's say the farmer discovers his prized goat can swim across the river before he begins to build, and he wants to place fencing on all sides of the rectangular plot. What is the largest area he can enclose now? So we still have our river here, right? But now he doesn't want his goat to escape, so he's going to enclose, it's not a very straight line, he's going to enclose the whole fence here, right? So it's some x and y and x, and this is also y. So this time what happens is my perimeter, if I were to walk around, like let's say I start here and I walk all the way around, the total distance around is y plus x plus y. So I'm walking around this way, and then now I'm walking this way. I get to the end of this one, plus x. Oops, not plus 2, plus x. So that's equal to 2x plus 2y. And I'm still, my farmer only has 4,000 meters of fencing. So 2x plus 2y is equal to 4,000. Okay. And again, I'm looking for my largest area. So if I think about my area, I'm using the same equation. It's x times y, right? Because that's going to give me what the area inside of this pen is here. And so again, I want to get the area in terms of one variable. You could pick either x or y in this case because it's equally easy to solve. I'm going to use y again. So this time I'm going to say 2y equals 4,000 minus 2x. And then I'm going to divide everything by 2. So make sure you do both terms on that far side. And I'm going to have y equals 2,000 minus x. So you see it's a little bit different. All right. Now we're going to take this y, we're going to put it into our a equation, or my area equation, and I'm going to make an equation a of x, because it's going to be just a function of x, is equal to x times 2,000 minus x. So that's equal to 2,000 x minus x squared. And this looks really familiar. I have an equation of a quadratic again. Again, I want the largest area, so I'm maximizing an area, and the maximum is going to happen at the vertex. So I'm going to use the equation negative b over 2a and area of negative b over 2a. And again, I want to find the largest area, so I want to find this. But to do that, I need to find this, right? I need to find what my x length is. So I'm going to say x is equal to negative b over 2a, which means it's equal to negative 2,000 over 2 times negative 1. If you come up with a negative number coming out of here, you probably did something wrong because you can't have a negative length. So you probably dropped a sign somewhere. So here, again, my x length is 1,000 meters. All right, so this is 1,000 meters over here, and it's 1,000 meters over here. If I wanted to find my y length, though, it's going to be a little bit different because y is going to be equal to 2,000 minus 1,000, which is going to be 1,000 meters. And you'll note that's a box. And whenever we look at maximization problems with like rectangles, the maximum, if I'm enclosing all four sides, is always going to be a square because that gives me the maximum area inside. So we can again do the same thing we did the last time. We can either use my area equation from here, or I can substitute into my function. If I substitute into my function, I have a of 1,000, which is going to be equal to 2,000 times 1,000 minus 1,000 squared, which is going to be 1,000,000 meters squared. Okay, again with the units. And if I were to use a equals x times y, since I found y, then it would just be 1,000 times 1,000, since x and y are the same. And that's going to be also 1,000,000 meters squared. So you can actually kind of check your work. These are the same, right? So you can see how when I'm enclosing the four sides, the function's a little bit different that I get for my area, right? Because the perimeter that I have to enclose, the fence I have to use for the perimeter is different than what it was when I enclose all four sides compared to when I just enclose 3 of the sides, which kind of makes sense. And that's kind of the difference between the problem on the last test where there was the barn or there wasn't a barn there and you had to enclose all four sides. So if you have any questions on this one, I'm going to do one more video that actually shows you about minimizing the area. So again, I had said whenever we see a quadratic and we want to minimize or maximize something or look for the largest or the smallest, we want to think about this vertex formula. And so I wanted to do one that was a minimization too, just so that you've got it, kind of an explanation of it. So let me know if you have any questions on this, and I hope it helps if you were still struggling with the areas or the maximization problem.